Good morning. There we go. All right. I'm not allowed to walk out of this zone. I'm a walker, so I apologize to anybody streaming if I step out of view. So again, good morning. My name is Chris Murray. I'm a technical marketing manager for the Unreal Engine Enterprise. I'm going to be speaking to you today about using the Unreal Engine in design visualization. But before I start, I'd be interested in a quick show of hands. Who has heard of Epic Games and the Unreal Engine? Okay, so I'm probably not going to have to talk. I'm done. I'm done, basically. No, of course not. Who has heard of using the Unreal Engine for design visualization? Okay, fewer amount of people. Who has played some of our video games? All right, about the same amount of people. Great. Glad to hear that. All right, so I'd like to start off by really showing you some amazing work by some amazing customers, just so you can see what it is that the Unreal Engine is being used for. So that's some pretty amazing stuff. I'm always impressed every time I see that. So a little background on Epic Games and why we're at a show like Develop3D when our history has really been about video games and entertainment. So we are a game developer. We've been here for over a decade and a half creating entertaining, fun, interactive game experiences. We're a publisher of games. And we're a technology company in that we make our technology readily and freely available. Our game engine is completely free. You can go get it today. So I'm not here to actually sell you anything other than to tell you and share with you what we're doing at Epic Enterprise. What this all means is that we eat our own dog food. We're not just creating a piece of software or a piece of technology that goes out into the wild and then when someone has a problem, they come back to us and try to explain it to us. Because we've probably already experienced that problem ourselves. Everything that's in the engine is derived from real-world practical experience of us trying to implement those things into the engine. So by doing this, this really gives us the ability to empower artists and developers to create some really amazing things. Quality is a very high bar at Epic. Good is never good enough, and we're always striving to really improve what it is that our customers are using and the quality of the pixels that they're creating on the screen. So our tool set is a complete tool set. Commitment. Our commitment to precision is really, really important. We want to make sure that you have the tools that you need to accomplish what it is you're trying to do. Again, our tools are easy and accessible. Like I said, they're free. And we refuse to dumb things down. There's a lot of interest around, kind of this one-click workflow and, seamless integration. We want the workflow to be as frictionless as possible, but we're not going to sacrifice quality of features or tools in order to make that possible. You're going to see some amazing things from some of our customers and things I'm going to show you here in a few minutes. And a lot of those things are only capable with a really robust tool set like we have in the engine. So our engine is really going beyond gaming. This is not the CGI that we all grew up with. Our customers are creating projects that engage, inform, and explore. TV, film, and advertising are really starting to notice our engine and use it quite a bit. I think you would probably be surprised. Did anybody happen to see the State of Unreal keynote that was streamed live from the Game Developers Conference last month? Anybody see that? You should probably watch it. It's really interesting. You'll be surprised to know that 3 shots in Rogue One are straight from the engine. Final pixels right to the screen from the engine. So Lucasfilm is paying attention to that sort of thing. Architectural design visualization companies are really starting to embrace our engine because as fast as GPU renderers are, hat tip to my friend Jamie here, people really want even faster. And with fast GPUs and fast graphics cards like AMD, we're really able to bring the rendering down to milliseconds. And that's our goal there. People are using our tools for simulation and training and serious games. And then you throw in AR and VR into the mix, and things really get interesting. A lot of the companies that you see at the bottom of the screen have embraced the engine and are putting it to use for telling all kinds of different stories, imparting information, and really experiential design. So what is Unreal Engine Enterprise? So I'm going to call this kind of a working title. Enterprise has only been around for about a year. We are truly part of the Epic Games ecosystem, but our focus is essentially on everything that's non-games. So automotive, architecture, aerospace, oil and gas. If it's not, shooting an alien or modding out a weapon, it's probably an enterprise product. So you can see a lot of different types of industries are taking advantage of us. And this is one of my favorite ones. This is also from the Game Developers Conference, and this was a project we did with General Motors. This is like the nexus of enterprise. So it's automotive engineering, it's entertainment, and it's VFX all in one shot. The image you see on the screen here is not a photograph. It is in engine. It's a real-time screen grab from the engine of the new Camaro ZL1. It's being composited real-time to a film quality standard using live dynamic HDR, playing back real-time. And that's just a screen grab. It was part of a Camaro configurator that was used this is an AR component using Google Tango, where you can actually configure the Camaro and then run it in a car commercial and configure it on the fly while it's in the commercial at film res on a backplate with real-time tracking. So all done in engine. So we were really excited to show that, and definitely if you get a chance to, that's also in the presentation, the GDC State of Unreal. This was just shown a month ago. You can certainly check that out. Film and VFX, virtual production, they're embracing the engine. They're using our engine for real-time tracking, real-time performance capture, and real-time performance playback. So the character you see on the left is being driven by a human actor, real-time, in photoreal. NASA has embraced using our engine for a hybrid reality lab. This is not a photograph. This is from the engine. This is a real-time screen grab from the engine of what you're seeing there. They were so convinced at the realism that they were able to bring, they integrated it into their astronaut training. Another automotive type of customer, BMW, is currently using mixed reality driven by Unreal to simulate different profiles of interior design in their cars. So they're using it for design review. You can see this is a thing called a bucket. They're in there, they have doors and seats and a steering wheel and a dashboard, but maybe they're looking at roof lines, hood profiles, maybe instrumentation configurations. Everything is being tracked in VR real time all through the engine. The other end of the automotive spectrum is the McLaren Configurator, which is here at the show, I'm happy to say, is here at the show today. You can go see it on the HP booth, where you can actually configure your own McLaren virtually via an iPad, change colors, textures, different car packages, and then it'll actually be waiting for you when you leave, because you can't get your car out of the parking garage. So, I'm kidding, of course. But no one laughed at that. That was actually funny. What is it here in the UK? Garage? All right. I'm working on it. I'm from North Carolina. What do I know? So, so you can actually see this. And again, you know, McLaren has a really high bar for visual quality, just like we do at Epic. And the car configurator meets their standard to put in front of their customers. And if you're aware of the price points of McLarens these days, you know that that's got to be really important. So we're very proud of this project. Architecture, engineering, and construction. Soluis, Martin's here somewhere, I think. You know, happy to embrace the engine using for architectural visualization, for pre-viz, for final viz. Lots of different people are using it for sales and marketing. Another one, Theia with Suffolk Construction, they're using VR to actually configure hotel rooms. So you can hold the Vive controllers, you can manipulate textures, patterns, move things around. I believe we also have this one here. I'm not sure if this one's here or not. I know we have a BBC Home in the VR stand. I don't know if this one is there or not. But if it is, be sure to check it out. It's really a great piece of work. Oil and gas, this is really interesting. They're using mixed reality, virtual reality overlaid with augmented reality, where they're actually tracking ROV subs on the ocean floor with 3D data that is matched up to the configuration of what's actually on the ocean floor. So the driver is actually able to operate the ROV in 3D real time with real-time telemetry coming back to the game engine and seeing everything that they need to, how they can navigate around in any condition underwater, because they're doing it in the engine, and then everything matches up to the real world one-to-one. So really, the Unreal Engine is going beyond gaming. We really are looking for live, interactive, immersive, and collaborative experiences. We want our content is we want it to be produced on demand, real time, obviously, and deliver on any device or in the cloud. We want to add dynamic cameras and interactions to your experiences, whether it's procedural content or sophisticated animations, simulations. Obviously, support for VR and AR, that's why we're here, right? So supporting all the VR devices that we can possibly do, large-scale displays, and of course, multi-user experiences. This really is driving the main goal of enterprise, and that's this right here, final pixels. Our goal is to give you quality, fidelity, and performance, but ultimately give you final pixels right on the screen. As my boss, Mark Berti, likes to say, we don't like to throw away pixels. So we want to give you the best quality right out of the engine as possible. And of course, this is interesting if you're really into VR. We now have a VR editing mode directly in the engine. We've converted the entire Unreal Engine editor into a VR interface, and you can actually edit the world that you're in VR. I've done it. It's amazing. And this can also be seen. Again, this is another thing that's available from the State of Unreal on YouTube. You can find that up there. So you can really immerse yourself in creating your content there. So I want to kind of talk about, you know, I said we eat our own dog food. Well, I'd kind of like to show you how the dog food's made a little bit. It's a little unusual for Epic to do this, but we feel it's important so that we can, you know, show you that we understand the workflows and challenges that you're facing. So Getting data to the Unreal Engine is really interesting, and because it's coming from multiple sources that have multiple different types of configurations and workflows, and everything's a little bit different. So I have 3 examples here that I'm going to share with you. This is an example of data that would be coming from DeltaGen, and I have the colored nodes are about data, materials, and lighting, right? So, and what happens to those things. And this is premised on a stop or not in 3ds Max. And I'm not going to go through every single step, because if I did that, we'd be here all day. Here's an example of what CATIA might look like. Here's an example of what Revit might look like. So for all these different types of workflows, you have an equally unique workflow experience. And so how do we capture all of that? Well, that is why Enterprise exists. Our goal is frictionless workflows from all of these different types of content creation packages into the Unreal Engine. And we're working to solve those problems. Right now, you can go get the engine for free, and you can do all of these things yourself. But our long-term goal at Enterprise is to develop tools that are enterprise-specific that will help facilitate the transition from your package of choice into any one of these experiences, regardless of your market. And that is why we at Enterprise exist. So I want to show you a little bit of where we are and where we're attempting to add value. Obviously, if I were to do a real workflow, again, that would be a week-long conference. So what I want to show you is just a couple of steps in the process. We started with some source data, courtesy of Motus Motor Cycles. This was done in SolidWorks. The example I'm going to show you here is only the engine, and we're going to focus on the engine has 1,500 unique parts, 4 million polygons, so it's just the engine. And that is what the motorcycle looks like from SolidWorks. You can see here we've gotten the engine into 3ds Max through some workflows. We're actually going to take a look at it with the RPR renderer. So here's the Radon renderer. I really like the fact that I can just drag an image-based lighting image in there and do my lighting. I don't have to do anything. So we're just doing some surface validation, just checking out, making sure that the surface is what we expect. And so it looks great there. Now we have to do a little bit of scene prep. So what we'll do is, again, 1,500 parts. Those are all of the pivot points for all of those parts. We need to centralize and localize those parts, or those pivot points, and so we do that. And this is all a manual process currently in Max. Wink, wink. And you can see where we are recognizing opportunities for us to improve your workflow. Then we have to add UVs, because if you want something in the engine to look fabulous, you have to do some UVs. So we have to go ahead and do 1,500 unique UV tiling operations on that, and then we're ready to export it to the engine. So you've seen the 2 or 3 steps in 3ds Max to do that, but on an order of magnitude of 1,500 parts. The last step is actually getting it into the engine. And the Max version was sped up. This one is actually playing back real time. So we're getting about between 20 and 50 frames per second. I've done the opposite here of what you would normally do. Sometimes you would hide, you'd only have the outer shell of objects and delete all the inner stuff. This is all 1,500 parts. This is all navigating real time in the engine. I'm able to orbit, move around. I can go into the engine. If I throw on VR goggles, I'll be in VR. And we have done some material work, so it's not a one-to-one relation of what you saw in the Max. We did actually do a couple hours worth of material work in here. But then we just threw on an animated camera and we're able to see it. So that's a good example of the typical workflow and what we can try to accomplish. This, by the way, is 4 million polygons. This is a non-decimated, non-LOD engine. 4 million polygons, 1,500 parts, playing back between 25 and 50 frames per second in the engine. So we haven't even started any optimization at this point. So I'd like to thank you for coming out. Please come check us out at the HP booth, and we're also in the VR theater. We're dedicated to working with you. We'd love to hear from you. Just like Jamie said, if you have the ability to share with us something cool that you're working on, you're working in engine, please reach out to us, enterprise@unrealengine.com. I'd like to thank HP and AMD for inviting us here. And with that, I'll turn it back over to Jamie.